Okay. Hello, my name is Carly. My partner Matt's going to be presenting in a second, but we are Team 8, and our project is analyzing basketball plays using computer vision. So, quick introduction. We are working with game film from the Duke women's basketball team, and essentially our goal is to build a tool that can extract player positional information, using computer vision, and then all of the potential implications of that, play identification, defensive spacing, things like that, that we can use by training a machine learning tool. So, really, one of the main ways that we're doing this is through pose estimation. You can see in the image on the right, all of those little green dots, orange dots, blue dots, those are key points that are being detected on each person, and so it's really our object detection model, and it's really useful within sports analytics, this key point detection, for things such as figuring out where their feet are, their hands, are they in a shooting position, a defensive stance, anything like that. It's great for basketball. So, talking about uniform color identification in general, we basically use that position or the key point estimations to extract a region from their shoulders to their hips. We convert it to HSV and then count the number of pixels within a given range. We essentially specify a range for each team's uniform color, and then we count the number of pixels. If a team has more pixels for one team, then they are assigned to that team for the frame. We're going to implement this with player tracking to assign it, then to a specific team after 50 frames to account for issues, which I'll show later. But here's an example. Essentially, if they have a green box on them, they're detected as the opponent. If they have a red box on them, they're detected as a Duke player. So I'll play that now. Okay, so cool. So in this video, really our goal is that the boxes aren't switching too much. They're constantly, or consistently being assigned to the same team. And so this is a pretty good example of that. But sorry. Some of the issues that I brought up, really skin color is one of the main ones. If the player's arm is the main thing in that bounding box region, we run into some issues. Also, poor lighting. Some stadiums don't have as excellent lighting, and then hair color is a big issue as well. You can see like the Ohio State player in this clip. Her dark hair is essentially the only thing in her bounding box region, and so it's not going to detect her as somebody wearing white. But yeah, I'll hand it over to Matt to talk about court isolation and player tracking.
Yeah, thanks, Carly. So the next thing that we're going to talk about is court isolation. And court isolation is a technique that we're going to use to identify which people are on the court and which people are off the court. So we use some classic computer vision techniques like identifying the intensity range of the court and binarizing for that range. And we get this result on the left-hand side, which is, it shows you the green mask, which is the mask of the basketball court that's being processed for every single frame of the video. And when we combine this mask with the MMPose data, we can tag individual people as being players, whether they're on the court or off the court. And so once we have the players identified, we need to transform their locations based on the camera's perspective to the aerial perspective. So this transformation is called a homography transformation, and we're using a technique called SIFT key point matching, which takes key points from both perspectives and then calculates the transformation between the two perspectives. And we added an additional intermediate step, which has the panoramic view of the court to improve the accuracy of this transformation. And the results of this process are actually very accurate. So what you're seeing here is on the bottom half of the video are all the people identified from the MMPose model. And on the top half of the video are their associated mapped locations to the aerial view of the basketball court. But we're still only processing each frame individually. We're not actually mapping or tracking these players yet. There's no continuity between the frames. So the last part of this project is we need to implement a player tracking algorithm. So our custom algorithm is based on the sort algorithm, and we're taking a Bayesian approach using the position, velocity, and acceleration of each player to predict the next location of the players, and then mapping the MMPose detections to that predicted location. And so that mapping process is using the Hungarian algorithm for matching with Euclidean distance. And then our customization of the sort algorithm mainly comes from incorporating the SIFT key points for each player into the Hungarian matching process to improve re-identifying occluded players, which is a really big problem for sports analytics. And so, yeah, so that's the next steps. We are completing the sort algorithm or the player tracking algorithm. If you want to see the beta results of that, you can check out our GitHub. But then after that, we can move on to really advanced analytics using this player tracking data, which will be exciting. And that's the presentation. Thank you. If you want to see any of the videos related to this project, you can check out the QR code here.